Hello, we are Andrea Lopez, Alvaro Garcia, and Elena Costa. This is our project for chemistry, chemical reactions that save lives.
We use cars in our daily use and sometimes there are accidents. Airbag saves us, but how do they actually work? We're going to talk about that in this video. According to studies, about 70 liters of gas are needed to inflate an airbag. So we use the formula for ideal gases to calculate the amount of sodium acid needed to inflate an airbag. We used for the pressure 1 atm, for the volume 70 liters, for the constant 0.08205 atm times liters over moles over Kelvin. And for temperature, we used 298.15 Kelvin. With this, we obtained the moles of nitrogen gas needed, but then we used the formula to find the relationship between the nitrogen and the sodium oxide. After doing the calculation, we could see that we needed a total of 124 grams of sodium oxide.
So, as an overall, speaking about the reactants and the products of the reactions, of the three of them, most of them are solids, in exception of the nitrogen. All of them are highly toxic or flammable, in exception of these two compounds, which are potassium nitrate and silicium oxide, and most of them are different type of solids. And the last product, which is an alkaline silicate glass, is a covalent network. It's very stable and harmless. But now here's another question. How must airbags be disposed? Well, as airbags contain many toxic components, after the airbag is inflated, it must be properly disposed. It cannot be used again because in isolation its components can turn into very harmful and toxic materials. So therefore they must be deployed while still in the vehicle, and the airbag, side airbags, and seatbelt tensioners should not be considered as reused parts or should never be installed in another vehicle.
For the two reactions involved in the inflation of an airbag, we have done calculations for enthalpy and entropy. In this case, to obtain if there is heat release or absorbed, and to know if there is more order and disorder after a reaction takes place. For the first, we obtain an enthalpy of minus 42.6 kilojoules, which means we have an exothermic reaction, and we have looking at the products, we have gases in the products, which means entropy, which will be positive because of the disorder of the particles. Then we will have an enthalpy in the second reaction of 399.45 kilojoules, and we will have a negative entropy because we have then solids, which will have a more order. And then at the end, we have a reaction that has minus 464.11 kilojoules.
Chemical reactions are very important in airbags to save lives because they help reduce the dangers that a human can experience in such big crashes. And it also helps us make sure that the inflation of the airbag doesn't harm the human in the prevention of a human being harmed by a crash. I think it's very important to understand how the elements react with each other and what they produce, as well as how they react in STP, because all of the factors need to be taken into consideration when thinking about what elements should be used to inflate an airbag. I think that all cars should come with a little manual about the right disposal of these airbags, as well as when a crash occurs. It's very important for authorities to know the procedure of the disposal because it is very important that we understand not just how these reactions work, but what they can cause. And we need to be responsible, and we need to make sure that even though it helped us and it prevents us from having injuries during a crash, maybe it can cause other things if we don't dispose of it correctly.
In this project, I have learned how a reaction can save a life. In this case, we study the airbags, and in this case, the after a crash of a car, the airbag or the reaction is induced to inflate the airbag. At the end, the division of sodium oxide into nitrogen and sodium will let the airbag inflate and will save the life of a person, absorbing the damage that the crash can happen has. And then I have learned also how to manage the reagents and the products because most of them are really toxic. And in this case, we learned that after taking the airbags out of the car, we need to give it to people specialized in this area so they can take the correct sanity procedures in order to avoid making damage in the nature and avoid making damage to the persons that are to the people that are around the reaction. And I think it was a really useful project and I liked it.
So, in my personal opinion, I think that these chemical reactions save lives due to the fact that with their combination, they are able to have a very high speed, which is what lets them react really, really quickly and save a life. And people must be very cautious when handling these reactants because they're toxic. Therefore, it is recommended to use glasses or special equipment or gloves when interacting with these materials. And people must be responsible of disposing of them when they're used because when they are in isolation they can be very harmful for the environment. Therefore, they must consult with a specialist what to do with them and dispose of them correctly.